Ever felt kind of boxed in by Java's rules? Well, today we're unlocking a powerful playbook for Java interfaces that's going to completely transform your code. Seriously, it'll make it so much more flexible and robust. Let's dive right in.
Okay, so let's kick things off with a little puzzle. Think about it. In real life, a person has one set of parents, right? But they can have multiple roles. They could be a manager, a musician, and a mentor. So how can a Java class, which can only inherit from one single parent class, pull off that same kind of versatility? The answer, you guessed it, is at the very heart of interfaces.
So here's our game plan. First, we'll see how one class can wear many hats. Then we'll explore how interfaces can create their own little family trees. After that, I'm going to give you a cheat sheet to keep all the rules straight. And finally, we'll tackle a tricky but super important rule about reference types that'll save you a ton of headaches.
First up, let's talk about that classic Java limitation, the one-parent rule for classes. It can feel pretty restrictive, can it? But what if I told you there's a really clever way around it? That's exactly where interfaces come into play, letting our classes take on all sorts of different roles.
And here is the fundamental difference right here on the screen. With classes, you are stuck with single inheritance, one parent. That's it. But with interfaces, a class can implement as many as it needs to. Just think of it like we said. You have one set of parents, but you can take on multiple jobs and you get different skills from each one.
This awesome feature has a name. It's called multiple implementation. What it really means is that a class can basically raise its hand and say, yep, I promise to fulfill the requirements, the methods, from all these different blueprints at the same time. This is the secret sauce for building objects that are both highly specialized and incredibly versatile.
Let's see how this works. Say interface A needs 2 methods and interface X needs 1. Well, if class B comes along and implements both of them, it's now on the hook for all 3 methods. It's a binding contract, you see. You have to deliver on every single promise you make, and that's what makes your code so predictable and reliable.
Okay, so we've seen how classes and interfaces play together. Let's take it up a notch. What about the relationships between interfaces themselves? This is where you can start to build these really powerful hierarchies of contracts, which makes your code even more organized and way easier to manage.
So this is the logical next question, right? We know a class can inherit from another class, and we know a class implements an interface. But how do you connect two interfaces? What's the magic keyword there?
And the answer is extends. Now, this is a really important point, especially for exams and interviews, so listen up. When an interface inherits from another one, it uses the extends keyword, not implements. And here's the real kicker. Unlike classes, an interface can extend multiple other interfaces, basically mashing them all together into one super interface.
So, what does this actually mean for your code? Well, if interface Y extends interface X, it just soaks up all of X's method requirements. So if a class then implements only interface Y, it doesn't get off easy. It's still on the hook for providing the code for methods from interface X. It's like a chain of command. You inherit all the responsibilities from the entire hierarchy.
Okay, are all these rules starting to swim around in your head a little bit? Don't worry, that's totally normal. We've got you covered. This next section is your secret weapon, a super simple cheat sheet that puts everything we've learned in one place.
Yeah, it's really easy to get these keywords and rules mixed up, especially when you're under pressure in an exam or a technical interview. So, let's just build a definitive guide, a single source of truth that you can use to keep everything perfectly straight.
This table, this is your ultimate cheat sheet. For real, memorize this. Let's just walk through it real quick. A class to another class, that's extends, and you only get one. A class to an interface, that's implements, and you can have as many as you want. And an interface to another interface, it's extends again, and you can also have many. Burn this table into your memory, and you'll have these core Java relationships down cold.
All right, for our last section, we're going to cover something that's a little subtle but incredibly important. This idea is a huge part of polymorphism, the ability of an object to take on many forms, and it's a rule that trips up developers all the time. But once you get it, your code is going to be so much more robust. Okay, look really closely at this line of code. We're creating an object of class B, sure, but we're storing it in a variable of type interface A. The whole key here is that the type on the left-hand side, the reference type, is what determines which methods you're actually allowed to call.
Honestly, here's the best way I've ever heard it explained. Think of that reference variable as your TV remote. The object itself is the TV, and that TV might have all sorts of fancy features. But if your remote only has buttons for power and volume, well, that's all you can do.
even if the TV has Netflix and a million other apps built in.
So let's apply that remote control analogy. Our obj references an interface A type, so its remote only has buttons for show and config. Now, even though the actual class B object that's sitting in memory knows how to run, our interface A remote doesn't have a button for it. If you try to call obj.run, you'll get a compiler error, plain and simple. The reference type limits what you can access.
So, what's the big takeaway from all this? Interfaces aren't just some random Java feature. They're a whole design philosophy. They give us the power to build systems that are flexible, modular, and way easier to test and change down the road. The real question now is, how are you going to use this power to write cleaner, more adaptable code? That's the real challenge and the real reward.